The question is the electronic configuration of silver atom is D block elements are seen from 3rd group to 12th group. They are arranged in 3D series, 4D series, 5D and 6D respectively. Silver is seen in 11th group in the periodic table. It falls below copper, silver and gold. 3D series are the elements where the 3D electrons get filled. 4D series, 4D orbitals, meaning 4D electrons will get filled there. 5D series where electrons fill in 5D orbitals, which are followed by argon configuration in 3D series, krypton in 4D series, xenon in 5D series. So silver should have 4D configuration followed by krypton configuration. The option should be either C, that is krypton followed by 4D series, and D, krypton followed by 4D series. And here krypton is in 3D series, therefore it cannot be the option. And here you see 5D series, even that also ruled out, cannot be the option. The answer should be C or D here. In these two, when we talk about the configuration of these elements, 11th group elements should have 3D 9 4s2 electronic configuration, but they violate half-bow principle and they show 3D 10 4s1 electronic configuration. As D electron, when it is completely filled, it gains extra stability. This way, completely filled, it gets extra stability. In order to possess that extra stability, the configuration changes from 3D9 4s2 to 3D10 4s1, whereas silver from 4D9 5s2, it jumps to 4D10 5s1 configuration, followed by krypton configuration. Therefore, our answer should be C option, where krypton followed by 4D10 5s1 configuration. The question is like this: which of the following is the correct sequence of atomic weights? We have to find out the correct sequence of atomic weights of the given elements. The given elements here are nickel, cobalt, iron and so on. They all belong to 3D series, and these 3D series elements are seen in this way according to their atomic number. First iron is seen, then comes cobalt, then comes nickel. According to their atomic number, they are arranged in this way across the series. Across the series, it is found that atomic size gradually decreases. As atomic size decreases, atomic mass increases for the element. Therefore, according to this, we can say nickel will have more atomic mass than cobalt, and then comes iron. But this option is wrong. Why? Because nickel is seen in several isotopic forms. Several isotopes it sees, And these several isotopes are very light. Several light isotope forms it is seen. Whereas cobalt is seen in only one form. It is monoisotopic of heavy atomic mass. These lighter isotopes will make nickel to have less atomic mass, because if any element is having several isotopes, then we take average atomic mass, where average atomic mass is nothing but the mass of isotope into their percentage abundance plus continues the same, the mass of isotope plus percentage abundance, which is divided by 100, then you get the average atomic mass of that element. As nickel has several lighter isotopes, obviously the atomic mass, average atomic mass, becomes lesser than cobalt. Therefore, cobalt will have more atomic mass when you compare with that of nickel, and iron, obviously having bigger atomic size, will have lesser atomic mass. Therefore, the option C is correct here. Cobalt is having more, then nickel, then iron. As nickel has several lighter isotopes, and we are supposed to find out the average atomic mass, which will fall lesser than cobalt, which is monoisotopic. Therefore, our answer will be C option. Here the question is, match the list 1 with list 2, and we are given with metal ions and magnetic moment. So, magnetic moment can be calculated. Magnetic moment of an ion can be calculated using formula root n into n plus 2 Bohr magneton. N is equal to number of unpaired electrons. Here, when we take valence electrons minus charge on the ion, we get deconfiguration. From deconfiguration, we can find out the number of unpaired electrons. That is D unpaired electrons, from which we can find out the magnetic moment. Let's take the examples. Cr3+. Valence electrons of chromium is 6. Charge given here is 3. Therefore, the deconfiguration is D3. There are 3 unpaired electrons in Cr3+. The next one is Fe2+. Valence electrons are 8 in number. 2 charge. Then it becomes D6 configuration, where there will be 4 unpaired electrons. Nickel 2+. Valence electrons are 10 in number. 2 electrons lost, so it will have D8 configuration, ends with 2 unpaired electron. Manganese 2+ has 7 valence electron, lost 2 electrons, will have D5 configuration, will have 5 unpaired electrons in it. Now, as per the formula, let's find out for chromium. It is 3 into 3 plus 2. So, it is root 15. Root 15 is 4. So, chromium will have 4 as the answer. Here it is root 4 into 4 plus 2. It is root 24. Here it is third option, so this will have 3. Here root into 2 into 2 plus 2. It becomes root 8, where the option is 5. This will be 5. Root 5 into 5 plus 2. It is root 35, where the option 1 fits here. So the answer should be 4351 for the ions. When you look at this, C option has 4351. Therefore, our answer should be C option here. The question is, atomic number of chromium ion are given 24, 26. Which of the following is paramagnetic with the spin of electron is given? We know ions having unpaired electrons, ions with unpaired electrons are paramagnetic. Now our task is we have to find out which ion in this has unpaired electron. To know this one, we should know the oxidation state of the particular atoms given here. Now let's find out the oxidation state of all the ion atoms here. Then we will understand the unpaired electrons. Any complex combined with the CO ligand will always have zero oxidation state, meaning FeCO5 complex, CrCO6 complex will have zero oxidation state for iron as well as chromium. So these options B and D options are ruled out options. Now let's talk about A option and C option. A option CrNH3 taken 6 times 3 plus. Here amine is a neutral ligand. Therefore, whatever the charge carried on the complex will be the charge of the ion. Meaning here chromium exists in 3 plus state. Whereas in this complex, that is FeCN6 4 minus, cyanide is an anionic ligand with -1 charge. There are 6 atoms, therefore it is -6. When you take out the charges outside the complex, it becomes +6, and therefore ion exists in +2 oxidation state. Meaning in this complex it is in 2 plus oxidation state. To find out valence unpaired electron, the valence electrons of chromium is 6 minus 3. Therefore, it has 3 unpaired electrons. When we talk about iron Fe2 plus ferrous ion here, ferrous ion, cyanide being a strong ligand, it will pair up the unpaired electrons. Look at this. It has valence electrons 8 and lost 2 electrons. It ends with 6 electrons. That is D6 configuration. Those 6 electrons are arranged this way according to Hund's rule. There are 4 unpaired electrons here, but cyanide being a strong ligand, it will pair up the unpaired electrons this way. When they pair up, the orbital picture becomes this way, where there are no unpaired electrons at all. There are 2 vacant orbitals, no unpaired electrons here. So Fe2 plus in this complex will have 0 unpaired electrons. Finally, Chromium is the one which has 3 unpaired electrons and shows paramagnetism, whereas Fe2 plus having 0 unpaired electrons will not be paramagnetic in nature. Therefore, our answer should be A option, which will show paramagnetism. The question is like this: which of the following ions form most stable complex compound? A metal when combines with a definite number of ligands. A definite number of ligands that forms complexes. If metal makes a strong bonding with the ligand, then those complexes are called as stable complexes. Now our question is, which of these divalent ions will form a strong bonding between ligand? We have to figure out. The ions given here all belong to 3D series, and when we arrange these ions according to their atomic number, they are this way: manganese, iron, nickel and copper, all divalent ions in 2 plus state, this way. And we know that in 3D series, across the series, the atomic size decreases. As the atomic size decreases here, the effective nuclear charge increases. Here, cupric ion Cu2 plus will have very high effective nuclear charge, as the size of the atom is very small comparing with that of the others. It has high effective nuclear charge, and this effective nuclear charge pulls the ligand firmly. It pulls the ligand very firmly, meaning the electrons from the ligands are pulled by cupric ion strongly, and cupric ion makes a strong bonding with the ligand comparing with that of the rest of the ions. Therefore, cupric ion will form a stable complex compound, and our answer should be A option. Here the question is the basic character of the transition metal monoxides. The basic character. Basic character can be understood by knowing the tendency of losing electrons. Tendency to lose electrons. Any metal which has more tendency to lose electron, meaning greater tendency to lose electrons, then they will have greater basic character. They have a greater tendency to lose the electron, then they have greater basic character. The atoms given here in these monooxides are like this: titanium, vanadium, chromium, iron, etc. When we arrange them according to their atomic number, titanium falls first, then vanadium, then chromium, then iron across the series. The atomic size across the series decreases. As the atomic size decreases, effective nuclear charge increases. Effective nuclear charge increases. If nuclear charge increases, the tendency to lose electron decreases. Tendency to lose electron decreases, meaning therefore basic character also decreases. Basic character decreases. As the tendency to lose electron decreases, even the basic character decreases, and this decreases when the effective nuclear charge increases, and that happens when the size is very small. Therefore, the basic character decreases this way as the size decreases. So the option should be this way, like that, and that falls A option here. So A option is right. The question is general electronic configuration of outermost and penultimate shell. N minus 1 is called penultimate shell, and NS or N is given as ultimate shell. N is ultimate shell or also called as valence shell. In the question, we are given with N value as 4 and X value as 5. We are supposed to find out the number of protons in the nucleus will be here. The number of protons is what we are supposed to find out. Number of protons is nothing but the number of electrons in neutral atom. So when you find out the number of electrons, we can find out the number of protons, which is otherwise the atomic number of the element. Now let us apply this configuration, that is N minus 1 S2 N minus 1 P6 N minus 1 dx ns2. When n value is equal to 4 and x value is equal to 5, when we substitute, it becomes 4 minus, it is 4 minus 1, that is 3 S2, and here also 4 minus 1, that is 3 P6, and here 4 minus 1, that is 3 D, and the x value is taken as 5, so it is 3D5, and this n value is 4, so 4S2. The valence configuration is 3D5 4S2, meaning it has 7 valence electrons here, 7 valence electrons here, and atoms which belong to which has an atomic number of 25 will have 3D5 4S2 electronic configuration with 7 valence electron, meaning atom with the 25 atomic number will show argon configuration, which is nothing but 18, followed by 3D5 4S2 configuration. So the atom's atomic number is 25, meaning the number of protons are 25 here. So our answer should be C option here. The question is like this: the correct order of increasing oxidizing power. Oxidizing power is the tendency for reduction. Elements with reducing property, meaning undergoing reduction, will have positive SRP value, positive reduction potential values. Meaning, greater the oxidizing power, greater will be the tendency for reduction, meaning greater will be the positive SRP values. When you look at the 3D series elements, across the negative SRP values decreases, meaning the tendency for reduction increases. Tendency for reduction increases. When we look at the ions given here, across the series, vanadium comes first, then chromium, then manganese. As negative SRP value across decreases, meaning tendency for reduction increases. Greater the tendency of reduction, greater will be the oxidizing power. In this, manganese has more tendency for undergoing reduction because it has lesser negative SRP value. So this will be having more oxidizing power compared with that of this. Negative SRP value decreases. It says that the tendency for reduction increases, meaning slightly positive value it shows, meaning tendency for reduction increases, greater will be the oxidizing power. Therefore, our option A is right here. The question is, an element is in M3 plus form. Its electronic configuration is 3D1. The ion is. Here we understand metal element after losing 3 electrons, it will change into M3 plus state, trivalent state. And here it gets 3D1 configuration followed by argon configuration. We are supposed to find out the metal ion. In order to find out that, let's take the configuration. 3D1 configuration. For this, add 3 electrons which are lost during the formation of metal ion. So when we add 3 electrons, first electrons enters into 4s orbital, 2, and the rest enters into 3d orbital, where already 1 is there and you add 1 more here. Now the configuration becomes 3d2, 4s2 followed by argon configuration, meaning it is 4 valence electron here, and the element should be titanium, whose configuration is 3d2, 4s2. This titanium, after losing 3 electrons, that is 3d2, 4s2, out of this, by losing this 2 electrons here and 1 electron here after losing, it finally ends up with the 3d1 configuration, and titanium changes to Ti3 plus state. So our answer should be A option, that is Ti3 plus.